Welcome students, welcome back to Horizontal Asymptotes, Part 2. Now I've got a little example here, and this is kind of stuff that we looked at in the previous session, so I'm just going to refresh your memory here. When we're looking at this function here, we've got quite the polynomial on top and on the bottom, but when we look at the end behavior, or the extremes, as x gets bigger. Remember, that's what we're talking about. We're not talking about around 0 here, when x is 0 or x is 1 or 2. We're talking about as x gets bigger. You know, x is now 1,000,000, or x is 1,000,000,000, and so on. Okay? So as x gets bigger, what's going to dominate here is this guy on the top. Okay? The 2 doesn't make that big of a change, and all these other terms are so small compared to x cubed that's what dominates on the top. And when you look at the bottom, this is the one that's going to dominate on the bottom. Okay? And so it ends up behaving an awful lot like 1 over x. And anytime we have 1 over x, we know that its horizontal asymptote is the x-axis, which is y equals 0. Okay? So that's what we looked at before. So anytime you've got basically a bigger degree on the bottom than you do on the top, then the horizontal asymptote is the x-axis itself. Okay. Now, what happens if you got a function where the degrees are the same? Like, let me just give you an example here. What if you look at it and you go, hey, it's a little bit different here because I've got, actually I'll just wait till I finish writing it all out. Okay, and maybe we have this on the bottom. Okay, so this time I look at, well, what's dominating here is x to the 5th. Okay, so I look at this term, I go, yeah, x to the 5th. But wait, there's x to the 5 on the bottom as well. Okay, so in that case, the way we analyze it is we can't ignore the 3. We can ignore the 2x and the minus 9, and we can even ignore x to the 4. But what we can't throw out is the 3, and so what we say is, well, the first term, which is dominating, the top, is x to the 5th with a 3 in front. And on the bottom, what's dominating is x to the 5th with a 1 in front. Hey, look, if I simplify this now, just cancel these guys, this is just like 3. And so that means that our horizontal asymptote is x equals 3. All right? So what you're looking for is when the degrees are the same on the top and bottom, that is the one that dominates, then you have to look at the coefficients, the numbers in front, because they're going to help you determine what the actual horizontal asymptote is. And keep in mind, what we're talking about here is that when you draw the graph of this thing, we're saying that when you head off quite a ways down, eventually the graph will settle down and it might approach from the bottom or it might approach from the top. But that's the value it's trying to approach. And the same thing is going to happen over on this side. It's either going to come roaring up from the bottom or it'll come settling down from the top. Okay, that's what we're saying when we say y equals 3 is a horizontal asymptote. Let's just do one more and then we're probably good with horizontal asymptotes. So let's look at a function that might have something like this. Maybe we've got 5x to the 7 minus 9x cubed plus 12. And again, we don't really care. The moment we determine that's what's dominating, that's all we're really looking at here. Now let's see what we could do with the bottom. Say we had 2x to the 7 minus whatever you like, 3x to the 4. I mean, really, all these terms are meaningless, right? Because what we're going to do is say, hey, these guys are what dominate. Not this, not this. not this, and not this. So we're really just looking at this. And the x to the 7's cancel. So what's going on is we're getting a function value that's approaching 5/2. So this is our horizontal asymptote. You know, sometimes it's a fraction. It doesn't always have to be a whole number or 0 or something like that. All right, well, that's where I'm going to stop. And we'll come back with more asymptotes.